Okay, this is how I'm gonna go over and set up for doing page 6 through 7 from your student notes. It's titled More Practice, and you're going to do numbers 1 through 16. And I'm going to post those instructions as well. Okay, starting out with, we have problem number 1, and it asks us to find the value of x in each of the following. So for problem number 1, and I think except for maybe the first part of the day, I did this for several classes. This is the triangle and the circle they have drawn. And I explained that this is circle C because it's got the C in the middle, which means that's the name of the circle. From here to here is where the 6 is. That is the radius of the circle. From here to here is also a radius of the circle. And since all radii of a circle are equal, if from here to here is 6, then from here to here is also 6, making the distance all the way across this particular line segment 12, because you say 6 plus 6. Okay? Now, because the diameter or the radius is perpendicular to a tangent, which is this line right here, then we have a right angle right here, so we have a right triangle. The right triangle looks like this, where this is 12 because part of it's 6 and the other part's 6. This side's 25, and this is the side we're asked to find. The Pythagorean theorem states that a squared plus b squared equals c squared. So a is 12, b is x, and across from the right angle is c, which is the hypotenuse. Plug these numbers into this formula and solve for x. And you're going to get a decimal number, so round to the hundredths place, which is also on the instructions I'm going to send, which is 2 decimal places. Okay, and also as a reminder that if you have a number that's squared, to undo that, you take the square root of that. Okay, so which is what you're going to have to do. All right. For problem number 2. Okay, for problem number 2, we're told that when 2 lines are tangent to the same line to a point outside of the circle, then these 2 parts are congruent to each other. Congruent meaning they are equal. So on that particular problem, this line segment and this line segment are equal. So 2x plus 13 and 4x minus 8 are congruent, which means they're equal. So 2x plus 13 is equal to 4x minus 8. And as I told several people today, if you are still having problems on solving equations, then you need to either come in to get some extra help, or you need to let me set you up some stuff online that you can do. All right, so the first problem was like exercises 4, okay, 5 and 6, but mostly 4. And this problem is like the ones we did today, so that would be from the do now, as well as exercises 7 and 8. Okay, and I'm going to do number 8 and post it along with the stuff from today that you need. Okay, number 3 gives us 2 circles, and they have the lines coming out, and I drew it up on the board in case you couldn't read what this says. It's just like number 2. Okay, so it's just like number 2. The only difference is we've got 2 circles that are side by side. Okay, and this side says 6x plus 5. This is C and this is C prime. And this is 37 minus 2x. Well, since this tangent is equal to this tangent, because they both go to the same point outside the circle and they're tangent to the same circle. And since on this circle, these 2 tangents go to the same point outside the circle, So it has to have the same arc as this side. So by the transitive property, if this is congruent to this, and this is congruent to that one, then the first one and the last one have to be congruent. Okay? So that means 6x plus 5 has to equal 37 minus 2x. Solve for x. Okay? Number 4, I'm not going to go over because it's worth 20 extra points, but I can tell you that on number 4, you're going to need to factor. X squared will not cancel out. Okay, and that's the only hint I'm going to give you because it's worth 20 extra points, but you must show all of your work in order to get extra credit for that. Okay, and in case you didn't get this part for your circle, it'll be on the sheet that I'm going to attach, but just in case, it looks like this. And what I said underneath it was that BD is equal to X. So that means from point B to point D is X. But you also got to know what CB is in order to get the length of CD. That's another little hint there for you. Okay, for number 5 and number 6. Okay, on your paper it says, one says if you have the diameter, find the radius, and the other one says if you have the radius, find the diameter. Okay, from your notes, you should know the following information, and I have this written on the board today. The diameter is equal to 2 times the radius, which means D equals 2R. The radius is half the length of the diameter. So that means R is equal to D divided by 2. Okay? So all you have to do is plug in and solve. So I'm not going to go over how to do that because you should be able to figure that part out. All right. For number 7 through 14, I thought it was through 12, but through 14, those are vocabulary words. All right, so what you're going to do is you must match up the vocabulary word with the correct line or line segment in the figure. Now remember, the difference is this is line AB, which we write as AB with a line over it, with the arrows, okay? This is line segment AB in that it has a starting point and it has an ending point. So when we write the abbreviation for that, it's AB with a line over it. Line segment. Make sure you name them correctly or look for the right one, because on one of them they've got the same letters, but one's a line and one's a line segment. The only thing that's not in your notes is what an internal and what an external tangent is. Okay? An external tangent or exterior tangent connects the point of tangent from one circle to the point of tangency to the other circle, but they're outside those two circles. And of course it is a line, so it would be line EF. Okay, that would be the common exterior. The common interior would be in between. So that's going to be the pink line I drew right here. So that's going to be line WX. Okay, so the common interior is the pink line. It joins point W to point X, which are both radii of your circle. Okay, and then because it lies in between the two circles, so it's interior or inside. EF is the common exterior tangent in that it is outside of the two circles, and it joins the points of tangency. Here it joins the points of tangency. Another word they'll use is internal and external. And that's what you're going to see on the other note sheet that I'm going to send out to you. Okay? Also, it could be just a point for your vocabulary well, because the center is just a point, the center of the circle. Okay? All right, number 15 and 16. Sorry, transformations. All right, so you're going to graph them. I gave you a sheet of graph paper. You're going to graph them. Go back and look at exercises 1, 2, and 3, which I've already done videos on. Okay, so the first thing you're going to do is graph both circles using the center point and the radius. Then you're going to describe your transformations. Remember, we first did a translation on how to move the center of the circle. Then we did a dilation to either make it smaller or larger, depending on which one it is. And I told you to do the scale factor to find what you're going to need to use. It's going to be your new image over your pre-image, which is what you started with. So where you end over where you began. Okay? But all of that, go back to exercises 1, 2, and 3, and it'll tell you how to do 15 and 16. Okay? All right.